So what is a limit? So the key word to remember for limit, if you wanted to summarize it into a one-word definition, is the word closeness. A limit just means what are you getting close to? Whoops, my iPad slipped. And slipped again. Okay. All right, so you want to think of a limit as being like a boundary, or it could be a number that you're approaching but maybe never equal or get to, or it could be the value that your graph is both approaching and going to be equal to. Right, so in other words, it's what number is the graph getting really, really close to as your x value approaches a specific number. So the intuitive definition for a limit is if f of x gets arbitrarily close to a single number L, as x approaches a value c from either side, we say that the limit as x approaches c of f of x is equal to L. So, right, we read this as the limit as x approaches c of f of x. Right. So that just says, like, if you were to look at a graph or look at the values around c, so say like c is 2 or something, as you approach that x value, so that number on the x-axis from either side, your y values are approaching a specific number, and in that case, it's L. So let's also go over the formal definition of a limit. So this has a lot of symbols in it, and like this is what I learned in college, and we actually had to use this to prove our limits. We don't do that in AP Calculus, but it's never a bad thing to know. So the formal definition of a limit is we are going to let f of x be a function defined on an open interval containing c. So that just means that we have an x equaling c value there. So what this means is that the limit as x approaches c of f of x is going to equal L, if and only if, which is the abbreviation IFF, if you remember that from geometry, for every epsilon greater than 0 that we choose. There exists a delta greater than 0 such that if the absolute value of x minus c is less than delta, then the absolute value of f of x minus L is less than epsilon. So what the heck does all that mean? So absolute value, remember, you can think of as a distance. So this is saying the distance between x and c is less than our delta value. And then the absolute value of f of x minus L is the distance between the function and the limit value. So what this all means is that, okay, so the epsilon is something we choose, and it's normally something that we choose to be pretty small, like 0.1, 0.01, something like that. So let's draw a little picture here. So let's say we have a function, right, f of x, right? So what we're going to say is, I don't know, maybe c is out here, right? So for this function, there's our L. So we're going to choose epsilon. So when we choose epsilon, epsilon is going to create a window around L. So what this means is that we create this little, we call it an epsilon neighborhood. So like this is L plus epsilon, and this is L minus epsilon, right? This distance here is epsilon. Right, so we're just creating like this little window around our limit. So what this definition says is if we pick epsilon to be whatever number we want, it can be as small as we want, then there exists a delta that we can place around our c value. So we can create a delta window around c. So this is like c minus delta, c plus delta. Where if we pick any value in between in that delta window around c. So like if I pick, say for instance, this, and I go up to my curve. Now this is gonna hopefully make sure I drew it out correctly, right? So basically, if I pick an x value in my delta window, the function should land me back in my epsilon window. So we use this as a formal definition of a limit because as we let that epsilon window shrink and get smaller and smaller and smaller, right, and our delta window is then also going to get smaller and smaller and smaller. Delta, by the way, you don't choose. You have to like do some arithmetic and some algebra manipulation to figure out what the delta has to be. Your delta is usually something in terms of epsilon. Right, so in other words, as we let epsilon get really small and we get really, really close to that limit value, we're also going to be getting really, really close to our c value. So it basically just says that like every point that's around that x equaling c value, the y coordinates there are also approaching the same value for L. You don't need to worry about memorizing this or anything. I just like to go over what the formal definition is